Finally, this is the last lecture. Let me introduce post-analysis toolkits, durability, and acoustics. RecurDyn has toolkits for post-analysis called durability and acoustics. Durability is a toolkit that performs a fatigue analysis using MFBD results. RecurDyn durability is a toolkit that calculates fatigue strength and durability such as fatigue life, fatigue damage, and safety factor from the stress and deformation results of a flexible body obtained through MFBD analysis. It provides the prediction theory for engineering fatigue and over 180 material libraries. RecurDyn Acoustics is a noise analysis toolkit that calculates the equivalent radiated power, ERP, which represents the noise characteristics based on the MFBD analysis results. Through distribution of calculated ERP, it is now possible to perform the predictive analysis for noise of the mechanical system by confirming which parts of the surface of a flexible body emit more noise and which frequency band the ERP is dominant. Let me introduce durability and acoustics through simple demo videos. A typical process of durability analysis consists of 3 steps. First, preference. This step is for basic setup. You can input parameters related to the notch or surface finish that affect the fatigue. The settings related to convergence control and rain flow counting can be done in this step. The next step is fatigue, and it is for settings such as axial mode, life criteria, material, time history, and so on. And calculation is executed in this step. Contour is a post-processing step using contour plot. Damage or life can be viewed by contour plot, and damage vector is also displayed visually. Let me introduce how to use durability using this model. First, you must complete an MFBD simulation to obtain its results. First, input basic settings in preference, such as parameters related to the physical state of the specimen, and values related to notch or surface finish, and so on. After that, click Fatigue. In this step, Life Criterion or Mean Stress Effect method is selected. Then select the material library and the element set for durability analysis. After specifying time history and occurrence, click Calculation button. Then you can check the durability analysis results. Now you can view the results using contour plot. You can choose either damage or life. Damage or life can be visualized using contour plot. Of course, you need to click the calculation button to calculate min-max. And please note that the damage vector can be also displayed. Typical process of acoustics analysis consists of 2 steps. First step is calculation. This step is for basic setup, which specifies the target patch set to calculate ERP. After inputting the speed of sound, air density, and sampling frequency, calculate ERP. The calculated ERP can be viewed through contour plot or scope. The key of acoustics is ERP. ERP, equivalent radiation power, is a well-known criterion to evaluate the structure-borne noise. The formulation is as follows. You can refer to this link for more information. I will introduce how to use acoustics with this model. As you can see, this housing is a flexible body. When you watch this animation, you can see that several parts are moving. This dynamic movement will cause the vibration to the housing. First, click the calculation button. Set sampling frequency to 5000 and select the target patch set. And ERP will be calculated using the data from frame 0 to frame 501. After calculation is completed, you can see ERP values in the frequency domain through this scope. Or we can also see ERP values in the time domain. After clicking the contour button, select Acoustics ERP type. You can check the ERP values for the specified patch set as contour plot. However, since the deviation of ERP values is very large, it is displayed only in blue. So, I will recalculate ERP again using the results excluding the value of the initial settling stage. That means I will exclude the results up until the 25th frame. You can see that the scope results are also displayed slightly different from the previous one. If you check the contour plot again, you can visually check which parts have the larger and smaller ERP values. I think I've covered most of the basics of what MFBD is. As this is a basic material, I did not explain the details. But if you understand the contents in this material, I think you can learn how to use it by yourself through tutorials or workshops. If you have any questions about MFBD, please post your questions to the forum of Function Bay technical support site. After watching all the courses of MFBD Kit, make sure you try the workshop in the link below. Thank you.